I welcome you all in this course of Introduction to Heat Transfer, a practical oriented approach. Today is lecture number 3, a heat modes of a heat transfer, an overview. Okay. Before this, we have completed lecture number 1, that is Introduction to Heat Transfer, and lecture number 2, and that is Thermodynamics versus Heat Transfer concepts. Okay. So I welcome you all once again. I am Amraraj Sawant from Department of Mechanical Engineering. Types of heat transfer. So before coming to the types of or modes of the heat transfer, let's once again recall the heat transfer definition. So heat transfer is a process of thermal energy movement due to the temperature difference. Likewise, I have said before lectures that the heat transfer is only occur because or when there is a temperature difference in a system. Okay, if there is no temperature difference, that means the process is in equilibrium and we can't predict how much heat is going to transfer in that system at that time. Okay, so basically there are three modes of heat transfer. First is a conduction, second is a convection, and third is a radiation. So here the figure illustrates these three modes of heat transfer. So let's see this in figure. The figure shows that kettle made up of, let's say, material or metal is placed on the burner. Okay, so due to the burning of this fuel, let's say LNG or LPG. Okay, so due to the burning of this fuel, the metal kettle will going to heat, and due to which the inside liquid will also get heated. So as we know, this is a simple thing. Okay, when you are going to make a tea, same thing you are going to do in your household. Okay, so how these three modes of heat transfer will takes place takes place at the same time, that is what we are going to see. So first, while this burning flame is in a contact with this metal kettle, and due to this contact the solid or the metal kettle is going to be heated. Why? Because the metal is having made up of some molecules and atoms, and that molecules or atoms will be vibrate with their central position, and some free electrons also will get transferred, and due to this transfer the heat transfer takes place, and that heat transfer is known as conduction heat transfer. Okay, and second one is this liquid, okay, which is placed inside this kettle will also get heated, but in some stages. While this burning flame is in a contact with this metal kettle, the lower layer of this liquid will get heated first. Why? Because it is in a just contact with a burning flame. Okay, so while this burning flame is having contact sudden or just before contact with this lower layer of liquid, this lower layer liquid will get heated up, and due to the heating of that liquid its density decreases. Okay, and while the density decreases, as you know the simple principle of physics, the lower density particle will always be float on the surface. Okay, and the higher density particle are sum up. Okay, so this lower density liquid will get heated up, and this will be lifted up. Okay, and afterwards this heavier or we can say the high density or cold water will also get deposited at a lower. Again the cold water which is coming from the top layer will also get heated, and this cycle will takes place in a cyclic process, and this is called as convection heat transfer. The heat transfer is mainly caused due to the motion of the fluid particles. Fluid means liquid or gases. Okay, another type or mode of heat transfer here is radiation. So burning flame, another type of or mode of heat transfer is a radiation. So this burning flame will cause heat transfer to this kettle, but due to some electromagnetic waves the burning flame will have experience, or the surrounding will have experienced some kind of heat transfer due to the electromagnetic waves, which is called as radiation. So all these three types of or modes of heat transfer we are going to see in details in further. So first is a conduction. The conduction occurs in solid, especially in metals. And why it is so? Because in first lecture I have summed up with this idea that the conduction heat transfer or the heat transfer in a metal is caused because of some vibrational energy due to the molecules and the atoms. Okay, the molecules and atoms will vibrate with their central position at somewhat extent, and some free electrons, and these will cause the temperature difference or a temperature gradient, okay, from where it is heated to the another side, and this will cause the heat transfer, which is called as a conduction heat transfer. So the heat moves via molecular vibration and electrons. Okay, so this conduction heat transfer will govern by the Fourier's law, and which is equal to Q is equal to minus K dt by dx, where Q is heat flux, that is heat per unit area, and K is thermal conductivity, dt means change in temperature, and dx is a total distance within which the heat transfer takes place. So this Fourier law we will see in details in further lectures. So types it is a steady and transient. In steady state means what? With the temperature the properties are not going to change, and here the property is a heat transfer, that is Q. And in transient the property where the here is a heat is going to change after or within some time frame. Okay, so that will also be going to see in details in further lectures. So applications of conduction heat transfer is electronic cooling and building insulation. So as you know that you are using laptop or some PCs, so in that the motherboard, which is made up of the highly precious metals, and that metals or the motherboard is must thing is that the cooling of that motherboard, because it will get heated up while processing your data. So that cooling or that heating up of that motherboard is due to the conduction. Also the building insulation. So you have seen in but right now not in India, but in some foreign countries like USA and UK, there are building regulations for which they have planned the building insulation or the wall insulation is a necessity there, but not in India. We will see this phenomenon and application in details in further lectures. So let's consider this slab or this square structure, okay, where the heat transfer is taken place from one side to the another side. Okay, let's say the one side, that is the one which is at left side, is a hot one, and one which is at a right side is a cold one. So at hot side, let's say the temperature is T1, okay, and at cold side the temperature is T2. As we see in a temperature gradient profile, the temperature gradient profile will always be linear in the conduction heat transfer. So this linear drop is taken place because this side is at higher temperature and this side which is at a lower temperature. So this block is having width of L length. Okay, so how this heat transfer will takes place? This heat transfer will takes place by the governing equation called as a Fourier law, which is where Q is equal to minus Ka dt by dx. Okay, so in convection, so how convection will occur? So convection is occurs in the fluid. Fluid means liquids or gases, or it involves both conduction and the fluid motion. What here I meant to say that in convection the conduction is occur between the fluid. What is, let's take this example. This is a cold can, okay, this is a cold can, okay, cold soda can, where the heat transfer takes place, as I given this example in a first lecture also. But right now, just if you observe that these arrows are the moving air, okay, beside this soda can. Okay, so this air will have molecules. Let's say this one molecule, okay, let's say this is one molecule and this is second molecule, let's say this is a third molecule. So conduction is a process of heat transfer occurs because only it is transferred because of vibrations or the free electrons of atoms or molecules. Here there are two molecules of fluid, okay, so these two molecules of fluid will be get contact with each other, okay, and due to this contact they are in a contact, they will have conduction phenomena, okay. And another is that the fluid motion, and due to this whole fluid motion with respect to this soda can, it will experience some heat transfer, and which is in this total effect is known as convection heat transfer. So this convection heat transfer, we are going to see the governing equation as a Newton's law, where Q is equal to HA Ts minus T infinity, where Q is a heat transfer, where H is a convective heat transfer coefficient, A is a surface area of that here as a soda can, surface area of soda can, Ts is a temperature of that surface, and T infinity is a surrounding air or surrounding fluid temperature. So types of convection heat transfer, there are two types. One is a natural and another is a forced convection. What is the natural convection and forced convection, that we are going to see in further lectures in details, okay. So application of this convection heat transfer are basically, first it is used or this phenomenon is used to design radiators and air conditioning. Why it is so? Because in radiators or air conditioning, the air or any cooling liquid is in a flow state, okay, and by flowing of this liquid, you can see here, by flowing of this liquid, we will have, or this soda can soda can will have experience heat transfer, okay. Always you can keep in mind that whenever or whatever be the state of motion of fluid or whatever may be the temperature, the heat transfer will always taken place from higher temperature to the lower temperature by second law of thermodynamics, okay. So third mode of heat transfer is a radiation. So basically the heat transfer via electromagnetic waves is nothing but radiation. So this radiation you will have experienced in a general life, the sun rays, and the heat energy from sun we are getting at earth from large distance. And why it is so? Because this radiation heat transfer doesn't require any medium, so it will travel in a vacuum also. So before this radiation, we have seen that the two modes of heat transfer, one is a conduction and another is a convection. Both of these two modes of heat transfer will require a medium, will require a fluid, or will require a metal to transmit. So before this radiation heat transfer, we have seen that the two modes of heat transfer, one is a conduction and another is a convection. So in conduction, we need atoms or molecules to transfer the heat. In convection, we need a fluid motion, that is a liquid motion or a gas motion. So but in radiation, we doesn't require any medium to transmit the heat, because the heat is going to transferred in electromagnetic waves, and so electromagnetic waves to transfer the heat, they doesn't require any medium, okay. So this radiation heat transfer, that is a one of the mode of the heat transfer, will govern by the Stefan-Boltzmann's law, which is equal to Q is equal to epsilon sigma 2 raised to 4. So this Stefan-Boltzmann law we are going to see in details in further lectures. So emission depends on the surface temperature. That is a very important phenomenon or very important factor. In radiation, the temperature or emission or heat transfer, which is mainly dependent on the surface temperature. As the surface temperature is more, the total heat transfer will be 4 times. Emission is majorly depends on the surface area or surface temperature. So the surface temperature is more prominent in this radiation heat transfer. So application solar panels and space heating. In solar panel you have observed that the sun, the energy came from sun, which is absorbed or which is used to used for working of PV cells, and that PV cells convert the heat energy or the radiant energy to the electricity. Similarly, the space heating. The space heating is a one type of the phenomena is used in space, and that space for heating the some part of let's say machines or whenever the heating is required, the heating is done by the electromagnetic waves in space. Why? Because there doesn't have we don't have any medium over there. Okay, so you can see that here let's say campfire, and this campfire will have propagate or will have electromagnetic waves, and due to which if you are set beside this campfire, you will experience a heat in the form of radiation heat transfer. So combination modes of heat transfer. Right now we have seen that the three modes of heat transfer, one is a conduction, another is a convection, and third is a radiation. But in actual practices, in real examples or in actual engineering applications or in day-to-day life, all these modes are simultaneously working in a practical life. Okay, so we are going to see how they simultaneously work, okay, in practical. So real world system involves multiple modes. Okay, cooking pan, you have experienced in your house that if you are cooking some vegetables, okay, over the cooking pan, then conduction will also take place. How? With that burner flame, the cooking pan is going to heat, and the cooking pan is made up of metal, and that metals having small or tiny atoms or molecules, and because of that tiny molecules will get vibrate with their central position and will have some free electrons, and due to which the metal pan will get heated uniformly, okay, or on the one side it will get heated so that the another side will also get heated, and that phenomena is called as a conduction heat transfer. Another is a convection. The cooking pan, okay, if you put a lid over that cooking pan to cook your vegetables, then the steam will get formed, okay, and that steam will have nature of fluid, okay, and due to which the density difference will create that what I have explained in before slides, okay, and due to which the heat transfer will take place, and that heat transfer is known as a convection heat transfer. And third is a radiation in cooking pan. As I have given one example before, is a kettle which is heated because of burner. Same in cooking pan, the radiation through the burner or the flames of the burner will be radiated in surroundings. That's why while cooking your vegetables, you also sometime will get heat transfer effect, or you will have some heating effect, okay, you feel that heating effect because of that burner flames also radiated heat to the surroundings, okay. Similarly in car radiator, you have seen that car radiator, okay. So car radiator is used for cooling the engine heat, okay, and that cooling the engine heat is also done by taking the ambient air, okay, in account, and the cooling of that engine, okay, is required. Why? Because so that the metal parts will not get affected due to heating or overheating. So in that car radiator, the conduction will occur when that coolant from the radiator will go to the engine. It will go to the engine in directly contact with the engine parts, okay. When that coolant is in a directly contact with the engine parts, then that coolant, within that coolant, if even that is a liquid, within that coolant the molecules will transfer the heat with each other, and that's why it is in a conduction state. Another is a convection. Likewise, I said the radiator needs ambient air to cool down, Okay, so the coolant to the air, that means the heated coolant will have to cool down with the use of ambient air. That's why the radiator are placed in front of your vehicle. Okay, and third is a radiation, that is to the environment. Even while you have used that coolant to cool that engine parts, but some form of engine or some part of engine will radiate or will transfer the heat to the environment. Why? Because in the form of electromagnetic waves, that is called as radiation. So heat transfer in engineering system, when we use it is these modes in engineering. So these are some examples. So first is a power plant. In power plant, likewise I have said in first lecture, what is a power plant? The power plant uses the coal energy to burn the fuel. Okay, or coal is used as a burning fuel, and that burning fuel is used to heat a water, and for by heating that water, the water is converted to steam, and that steam is going to pass through the series of turbines, and after that turbine the steam is going to condense in a cooling tower, and again this cycle will get repeated, and by rotating the turbine we will rotate the generator shaft, and by rotating the generator shaft we will create or we will generate electricity. Okay, so in power plant, the boiler where the water is get converted into steam. In boiler, the conduction phenomena occurs. Why? Because we burn the fuel to convert the water into steam, and how, by burning that fuel we transfer the heat in the form of heat to the water, and that system, okay, is placed by some tube and shell type arrangement, and that tube and shell type arrangement comes under the conduction. Why? Because always in a conduction, the conduction heat transfer will takes place. Why? Because just it is because the molecules of the metal or fluid will vibrate with their central position or the free electrons, and that will cause a transfer of heat. That's why it is a conduction. So in turbine is in power plant, in turbine, the turbine is device while it is rotated because of some high pressure and temperature fluid, and that rotation we will use it for further generation of electricity. So in that turbine, the convection heat transfer will takes place, and why it is because that high pressure and temperature fluid, liquid or gas, will strike the turbine blades, and by striking the turbine blades, the molecules of that fluid will transfer the heat with the flow of that fluid, and so with the flow of that fluid, the heat transfer takes place is convection. And also we have seen in first lecture that cooling towers, the convection heat transfer takes place as it is in an evaporation phenomena. Okay, so in automobiles, likewise in before slide I have said that car radiator. Similarly in automobiles, if you observe the engine block, there are many parts in engine block, so the heat will get transferred from one part to the another part in the engine block by the phenomena of conduction. So you have just keep in mind that the three modes of heat conduction, how they are takes place. First, conduction, the conduction heat transfer is taken place only because of molecular momentum and the free electrons. Second, convection, convection is taken place only because of the fluid motion. Okay, the fluid means liquid or gases. And radiation heat transfer is only taken place because of electromagnetic waves, and it doesn't require a medium. That were the simple three phenomenon and the simple three modes of the heat transfer. Okay, so radiator, likewise just before you have seen that in radiator the heat transfer modes is a convection heat transfer, and in exhaust, in general language you have called it as a silencer, but exhaust, the radiation heat transfer will take place. So in electronics, heat sink, fans and thermal cameras, that are the major applications of these modes of the heat transfer. Okay, so there are key equation for the heat transfer that all we are going to see in details in further lecture, but just right now you just go through it. For conduction we use Fourier law, and Fourier law Q is equal to minus K dt by dx. Okay. For convection we use Newton law of cooling, where Q is equal to heat, H is equal to convection heat transfer coefficient, A is a surface area, Ts is a surface temperature, and T infinity is ambient or surrounding temperature. So it is used, or it is governed by Newton law of cooling. In radiation, this equation is what we get from the Stefan-Boltzmann law, and these all three we are seeing these all three in detail in further lectures. Okay, just right now you keep in mind that these three modes of heat transfer will takes place, how it takes place, and what are the governing equation. For conduction the Fourier law is used, for convection Newton law of cooling is used, and for radiation Stefan-Boltzmann's law is used. Okay, so conclusion, all these three modes are crucial in thermal system design. Likewise, we have seen that in actual practices all of these conduction, convection and radiation are simultaneously working in a same practical or same example or same phenomena, okay, or same situation. So this application is span from electronics to power to space. So why the heat transfer is a more prominent or more important subject in your engineering? Because this heat transfer and the analysis of that heat transfer will takes place from electronics, power to the space, any area you can have in your engineering. So this is a basic and this is a must course you have to understand if you want to be a good engineer. So understanding each mode enables the energy efficient solution. So understanding each mode, you can efficiently manage how the heat transfer will takes place, how much I want to minimize and how much I want to maximize according to your applications. So thank you very much. After this lecture you will have an assignment and the online link will be provided in description box. If you have any query or doubts, you can feel free to talk to me in description box. Also this ebook will be published within 1 week, so feel free to ask me anything about this course. So thank you very much once again.